Hello and welcome, my dear students, to your CS class. Dear students, today still computer system and organization. This is second part of it, and we are going to learn today about computer memory. We have seen that memory is one of the parts of a computer system, isn't it? Along with the CPU, the input-output devices, and storage, memory is also an important part of a computer system. Now it is obvious, if you don't have a memory, where would you store data? All the data that we input into our computer system has to be stored. Okay, be it just little data, a large amount of data, 2 or 3 files, 100 files, maybe your audio files, your MP3s and MP4s, your images, all these are data and we need to store them in our computer system. Now let us begin. A computer system needs memory to store the data and instructions for processing. Whenever we talk about the memory of a computer system, we usually talk about the main or primary memory. The secondary memory, also called storage device, is used to store data, instructions, and results permanently for future use. So, in the introduction itself, we have seen we have the main memory, the primary memory, that is one, and the second one is the secondary memory. And the second memory stores the results of our instructions permanently for future use. Now let us see how we store memory. You see, the way for length we have meters, centimeters. Then when we are measuring our weight, we have kilograms, grams. Likewise, for units of memory also, we have different sizes here. A computer system uses binary numbers to store and process data. Now, we have something called binary numbers. Binary numbers are zeros and ones. Why does a computer system need binary numbers? Now, that is because a computer understands only binary language. A computer system is an electronic device. Okay, it's not a human being that it will understand all these alphabets. A computer system understands only zeros and ones. The binary digits 0 and 1, which are the basic units of memory, are called bits. Further, these bits are grouped together to form words. A 4-bit word is called a nibble. Okay, so you see, now 0 and 1 are called bits and 4 bits make one nibble. Now these are nibbles 1001, 1010. Whenever we have 4 bits put together, it creates one nibble. A 2-nibble word, that is 8-bit. Now when we double this 4 into 8-bit, it becomes a byte. Okay, so 4-bit makes one nibble, 2 nibbles make one byte. A bit is 0 and 1, nibble means 4 bits and byte means 8 bits. This is an example of a byte. Like any standard unit, bytes are grouped together to make bigger chunks or units of memory. Okay, so bigger sizes of memory, we are going to see them now. We said a nibble, one nibble is equals to 4 bits. Okay, look at it here, 1001, 1010, 0011, 4 bits, that is one nibble. Okay, then we have what is called a byte. Now byte has 8 bits. We said when we double this 8 bits, it becomes one byte. After that we have 1 kilobyte. Kilo means 1000. 1 kilobyte equals to 1024 bytes. 1 megabyte, MB, equals to 1024 kilobytes. Then 1 GB, which stands for gigabyte, equals to 1024 megabytes. Then TB, which is terabyte, equals to 1024 gigabytes. Then 1 PB, which is a petabyte, is equals to 1024 terabytes. Then 1 EB, which is exabyte, is equal to 1024 petabytes. Then we have 1 zettabyte, which is equals to 1024 exabytes. And then the highest or the largest size of the unit here is 1 yottabyte, which is equals to 1024 zettabyte. So these are units of memory. I know you all know about KB, MB and GB. Your phones have a data plan 1 GB, okay, per day, 1.5 GB per day. So 1 GB is equivalent to 1024 MB. Now 1000 GB is 1 TB. We have hard disks of 1 TB, 2 TB, that is 2000 gigabytes. So now imagine 1000, you keep on adding. It turns into a very large unit of memory. So for now, the largest unit we have is a yottabyte. You are supposed to know these units of memory by heart. So write them, practice them, they're very easy. Now let's look at the types of memory we have. Human beings memorize many things over a lifetime and recall from memory to make a decision or some action. Yes, it's obvious. You know, we have a good memory. A human brain is very strong. We save a lot of things. We save a lot of incidents. We memorize songs, poems, our work, our notes, and whenever needed, we try to recall them. However, we do not rely on our memory completely, and we make notes and store important data and information using other media such as a notebook, manual, journal, document, etc. So you see, when you are writing notes, you have to write 10 pages of note. You cannot completely memorize all that 10 pages exactly inside your brain. You can only memorize some of the ideas about it. The rest you have to write it. So similarly, the computers also have two types of memory, the primary and the secondary. Now let's look at the first one, the primary memory. Primary memory is an essential component of a computer system. Program and data are loaded into the primary memory before processing. The CPU interacts directly with the primary memory to perform read or write operations. Now see, whenever the computer starts, we switch it on, it boots and it starts. So as we begin working, maybe we have to write, we have to do some typing, okay? So when we save our file, it is saved in the primary memory. Why is it saved there? Because we are not yet processing it, we are not making use of the file, we have just stored our data. So the programs and this data, it is loaded in this primary memory before we start making use of it. It has two types, the random access memory and the read-only memory. Now let's look at the difference. The random access memory is volatile. That means it is available only as long as the power is supplied to the computer. It retains the data. As soon as the power supply is turned off, all the contents of the RAM are wiped out. It is used to store data temporarily while the computer is working. Okay? Now my system is switched on and I have a file, okay, and I'm making use of that file. Maybe I'm typing. Once I switch off my computer system, the power supply is disconnected. That data is wiped off. That means it is erased. It doesn't exist anymore. It is used only temporarily. It stores it temporarily. So the random access memory is volatile. It means it keeps your data only as long as power is supplied to the computer. And it stores the data temporarily. The second type is the ROM, which is a non-volatile. This means its contents are not lost even when the power is turned off. It is used as a small but faster permanent storage for the contents which are rarely changed. For example, the starter program, which is the bootloader that loads the operating system into the primary memory, is stored in the ROM. Now this is the reverse of the RAM. We said RAM is volatile, ROM is non-volatile. RAM cannot keep your data, store it, it wipes it off, but the ROM keeps your data. Even if your laptop or your computer is turned off, the contents, the data are not lost. Okay? It is a faster permanent storage and we can hardly change the settings. Now for example, the bootloader. Whenever you switch on your system, there is a process called booting. That is, the computer system's operating system is loading. An operating system, for example, Windows, Mac, iOS, or in your mobile phones you have Android. Android is an operating system. So when it is loading so that the device can work properly, it is called the bootloader or the booting process. We have another memory called cache memory. Now RAM is faster than secondary storage, but not as fast as a computer's CPU. So because of RAM, CPU may have to slow down. To speed up the operations of a CPU, a very high speed memory is placed between the CPU and the primary memory known as cache. It stores the copies of the data from frequently accessed primary locations, thus reducing the average time required to access data from primary memory. Okay, we have said that the RAM is a volatile memory. Okay, it does not keep your data permanently. It wipes it off once you take away the supply. Okay, once you switch off your computer, the data is erased because it was temporarily stored. The CPU has a secondary storage called the hard disk, okay, which stores memory in a very faster speed. Now, when the RAM is active, the CPU has to slow down. Okay? When the RAM is active, the CPU has to slow down. But if your CPU slows down, all your activities, your tasks, your commands, your instructions will also slow down. So if the computer has to work in a proper balanced speed so that no task will be slow, no instruction will be slow, there is a very high speed memory called the cache memory. It is placed between the CPU and the primary memory. Okay? The primary memory, which is the ROM and the RAM, it is not very fast. And the CPU is very fast, but it has to slow down. Now, for the operations to move in a normal speed, the cache memory is placed. What is the work of the cache memory? It stores the copies of the data from frequently accessed primary locations. That is to say, each time when you switch on your system and you keep on opening one same file, maybe class 11 computer science notes part 1, you have a document by this name and you open it every day. So it is a frequently accessed place. You are often or you are regularly or you are daily accessing that file. So the cache memory quickly stores that file. Okay? So it stores the copies of data from frequently accessed primary locations. Now we have the secondary memory. The primary memory has limited storage capacity and is either unstable or read-only. Now unstable, we are calling it RAM. Why? Because it is volatile. It does not store your data permanently. The moment you switch off your system, the data is wiped off. That is why it is unstable. A computer system needs support or secondary memory to permanently store the data or instructions for future use. Now, of course, we have important files. We need to store them so that we can use them later on. If we keep on depending on the primary memory, half of our data will be wiped off. So, if the computer needs to store files permanently for future use, then we need a secondary memory. The secondary memory is non-volatile and has larger storage capacity than the primary memory. Storage capacity, that is the size, the amount of space that it has for storing. It is slower and cheaper than the main memory, but it cannot be accessed directly by the CPU. It is slow, no problem, but then it is cheaper also. The contents of secondary storage need to be first brought into the main memory for the CPU to access. And the examples are hard disk, okay, the hard disk drive that is inserted inside the CPU. Then we have the CDs and DVDs.